Hello student. Okay, by using the Gauss theorem, now we will find the electric field. Okay, electric field. How we will find? See that electric fields due to line charge. Okay, suppose that we have a lines that's okay, and that's a very thin, but number of charges is placed over it. Suppose that we have a line. This is the y and y dash, and many charges placed over it. Okay, so suppose that q charge is placed, and the length of this line is L. Therefore, we know that according to definition of linear charge density, what is the formula? Lambda is equal to q. What is the formula? Lambda is equal to q by L. Okay, so q is equal to lambda, that you can write. Q is equal to lambda. Okay, lambda L, that we can write now. Okay, very good. So I have same. Suppose that like that. This is the line, and having charge plus q is placed over it. I have put here y and y dash. This is the axis. So you know that due to charge distributions over a lines, it will be like as a cylindrical forms. Okay. So suppose that length of the cylinder is L, and E is the electric field intensity. E is the electric field intensity, and R is the distance between where, suppose that this is the P is the point, O to P is the R, and ds is the elementary portion. Okay, so we can find out the electric fields on these totals, but before it we have to find out the elementary. Okay, so theoreticals I have written. Let us consider a thin infinitively long straight line charge having a uniform linear charge density lambda placed along this y and y dash. Okay, so electric flux through this Gaussian surface. This is the Gaussian surface, no? This is the Gaussian surface. So you can write phi is equal to E into area of curved surface of a cylinder having radius r. This is the radius r. Here is radius r, and it forms like as a cylinder. Okay, so what is the formula of the cylindrical? You can write here this formula. Okay, or you can write phi is equal to E into 2 pi RL. Can we write here? You put this is the equation first. But we have according to Gauss theorem, you can write phi is equal to q by epsilon naught. Yes, this is the formula that we have. Okay, already did that. Okay, so you can see that we have the two equations. One is the phi is equal to something, and here is also phi is equal to something. Is it correct? Now in both equation you can see that LHS is equal, so RHS will also equal. So from equation 1 and 2, by using this equation you can write here E into 2 pi RL equal to q by epsilon naught. Can we write here? And adjust this one. So or you can write E is equal to 1 by 2 pi, what you will write here? 2 pi epsilon naught. Okay, epsilon naught into q by RL. Can we write here? Okay, very good. But we have also formula. Since we have formula q is equal to, first you can write lambda is equal to q by L. Therefore q is equal to lambda L. Can we write here? So you can write here. Therefore equal to 1 by 2 pi epsilon naught. At the place of q you will write lambda L divided by RL. L and L will cancel out. You have E equal to 1 by 2 pi epsilon naught lambda by R. Can we write here? Or also you can write this formula, you can multiply by 2 also, or remain same you can write here. Or you can also write or E equal to 1 by 4 pi epsilon naught. We can multiply by 2. If you will multiply here, then upwards also you have to write. So here will be 2 lambda by R. This formula will also. Is it correct? So by using this long infinitively line charge, we can find out this formula. Okay, student. So you also write this question. That's very important. So you can find out the electric field. Okay, due to line charge. Okay, thank you.